Hi and Assalamualaikum. I'm Nelly Iman.
I'm Nur Aina Nabiha.
I'm Nur Hanisa.
And I'm Nur Farwiza Atika.
In this video, we will talk about how application differentiation to be applied in our daily life. Without further ado, we will go straight to the first part of this video that will be presented by Nur Aina Nabiha.
Hi! So first of all, I would like to explain what is differentiation. Differentiation is rate of change of anything with respect to something. Differentiation is a method to find derivative or instantaneous rate of change in function based on one of its variables. Let's say we have first variable is x, second variable is y, then the rate of change of x with respect to y is given by dy over dx. Why do we use differentiation? We use differentiation to find the rate of change of velocity with respect to time. And last but not least, to calculate the highest and lowest point of the curve in a graph or to know its turning point. Differentiation is also can solve some real-world problems. As example, to determine the speed or distance covered such as miles per hour or kilometer per hour. To check the temperature variation. And last but not least, to calculate the profit and loss in business using graphs.
Now we will go to the second and third part that will be presented by Nelly Iman and Farwiza Atika.
Next, our chosen problem. Problem statement. What to solve? An airplane is flying overhead at a constant elevation of 4,000 feet. A man is viewing the plane from a position 3,000 feet from the base of a radio tower. The airplane is flying horizontally away from the man. We can see an airplane flying at a constant height of 4,000 feet and a man is seeing the airplane. The question is, what is the speed of the plane if the distance between the person and the plane increasing at the rate of 300 feet per second? So, we have distance between man and airplane is increasing 300 feet and we want to search for speed.
This is how to solve the solution. If you look at the diagram given, it is a right angle. So we use theorem Pythagoras. But x and s are changing as the plane moves to the right. From here, we know the height is constant. This is the equation based on the diagram. We know for a fact the derivative of a constant is 0. So the equation should be 2x dx per dt equals 2s ds per dt. How do we get this equation? We differentiate in terms of t to find the speed. Then we can cancel out the two numbers, so it'll be x dx per dt equals to s ds per dt. Now we can replace the equation with the given numbers. So it will be 3000 dx per dt equals to 5000 times 300. How do we get the 5000? The 5000 is from the theorem Pythagoras if x is equal to 3000. So, if the plane is increasing at the rate of 300 feet per second, the answer for this question are 500 feet per second. Why does this question use application differentiation? Because from the diagram, we know the distance between the person and the airplane, and the person and the place on the ground directly below the airplane are changing. From this sentence, the keywords are changing. So, the best method to use to solve this question are using application differentiation. And the last part will be presented by Nuhanisa.
And lastly, what is the conclusion? To summarize the question about an airplane flying at a constant elevation, we use formula ds over dt to calculate the speed of the plane if the distance between the person and the plane is increasing. We use related rates formula to solve these problems. The rates of change is defined as dy over dx. Based on the question, we need to find the speed. So, for the question, the speed will change while the time is already fixed as the question already gives the rate of 300 feet per second. So, that's why we use the formula dx over dt to find the speed. After the calculation, we will get the answer 500 feet per second for the speed of the plane. The conclusion is, advantages using differentiation concept is to improve our understanding and it can help us solve many types of real-world problems. Differentiation concept gives many benefits to people, such as police can use this concept for tracking speed of a car that exceeds the speed limit. Next, this concept can also be used to derive many equations in physics. For example, in physics, the derivative of the displacement of a moving body with respect to time is the velocity of the body, and the derivative of velocity with respect to time is acceleration. This concept can also help people to find the range of magnitudes of the earthquake. After the explanation that we have explained, we hope that it could help everyone to understand about application of differentiation and enhance your knowledge about this topic and apply it on real life. That's all from us. Thank you.